Hi, I am Santiago Cordova and this is the video of my evidence 1. I'm going to solve this circuit by the methods of mesh. I already drew my circuit so I don't lose time. And the first thing I did is to find my currents, to define them. I defined them clockwise just because of convenience, and I put I1, I2, I3 and I4. The first thing is that we are going to see here that we have a Vx and we can define it in variables that we do know. So we can define it at 45 times the interaction of I1 minus I2. This can be the equation of our Vx. We are going to use it furthermore, so it is really important. The first thing we're going to do is to define the equation of our supermesh. Our supermesh is 2 of 4. The I4, we can see that it's going on the same direction of the current I1/4, so it's going to be the positive one. So we can put I4 minus I2 equals 1/4 of A equals 0.25. We already have our first equation. Now we're going to go to the mesh 2,4, because this one is the same mesh. We can start it by putting 37 I4 plus 45 times the interaction of I2 minus I1 plus 54 times the interaction of I2 minus I3. We do the proper equation and we would have that it's 37 I4 plus 45 I2 minus 45 I1 plus 54 I2 minus 54 I3. And we have our second equation. Our third equation, we are going to analyze mesh 1. So we can start by minus 5, because it's starting in minus, plus 30 I1, because we have no interaction, plus 45 interaction between I1 minus I2. We do the proper math equations and we would have 30 I1 plus 45 I1 minus 45 I2 equals 5. And we have our third equation. For the fourth equation, we're going to analyze mesh 3, and we would start by plus 6, because it's starting in plus 54 times the interaction of I3 minus I2 equals 0. So we would have 54 I3 minus 54 I2 equals minus 6. This we're going to plug in the calculator. I already did it just to save some time. And we would have that I1 it's equal to minus 0.066. I2 it's equal to minus 0.22. I3 it's equal to minus 0.333, and I4 it's equal to 0.027. Now we have this. We can go back to our Vx equation that I told you to remember at the very beginning. We have Vx equals 45 times I1 minus I2. If we plug in this would be 45 minus 0.066 minus 0.222 times 45, and this would be equal to 7.02 volts. And we have here our first answer. Then we need to have the power of this current source, but as we know, power is equal to B times I. We have I, but we do not have B, so we have to define this as B0. We can solve B0 by analyzing loop 4. What are we going to do is that we have 37 I4. This is going to the opposite direction, so we have minus B0, and this would be equal to 0. So we can solve for B0, and this would be 37 I4. And we can have that B0 it's equal to 0.999. And now we only need to do the power would be 0.999 times 0.25 amperes, and this would be a net power of 0.25 249 watts. And we have already solved.